Hello students, welcome to another tutorial from Brains Gossip, and today in this tutorial we're going to start with the new chapter of class 11, and the chapter is motion in a straight line. So basically we have decided to start a new series, and these lecture series will be on class 11th, and we'll try to definitely cover most of the portion of class 11. So keep in touch, and the language of these lecture series will be in English, but I'll also try to make some videos in Bengali also, so those viewers which are from Bengali medium background or from West Bengal, so don't mind, I'll make videos on Bengali, so don't worry. So this lecture series from class 11 will be on English, so keep watching.
And today we're going to discuss about class 11th third chapter, and the name of the chapter is motion in a straight line. And the topic we're going to cover today is general introduction of motion. My name is Devoshin, so let us start. Now, before we start discussing about this chapter, let me begin with a small interesting story. Suppose there is a thief who is running by stealing something, and there comes a policeman asking your help. Now, suppose this thief is moving with a speed of 20 meter per second in this direction. Now, can you guess what should be the speed of this policeman? Should it be greater than 20 meter per second? So it should be greater than that, or less than 20 meter per second. Obviously, if the policeman want to catch this thief, he should run with a greater speed than the thief, that is 20 meter per second. Now, if the distance between them is given, and suppose the distance is 100 meters, can you guess by which time this policeman can catch this thief? So, after completing this tutorial, you should answer this question. So, let us start. After completing this lecture, you will be able to learn the concept of frame of reference. You will understand the concept of point mass. You will be able to differentiate between rest and motion, and you will be able to compare different type of motion. Now, before we go into this topic, let me discuss something related to the previous topic, that is the units and measurement. Why do we need to measure something? We need to measure in order to understand what is happening over there. So that is why we need measurement. But don't you think before we measure something, we need to observe things first? Because if you do not know how to observe, then how you can measure, isn't it? So if we need to observe something, there comes another question, with respect to what? So, if we need to observe something, first we need to rest ourselves at a specific position, and that is called frame of reference. Now, why it is important to understand that we need to rest ourselves at a specific position? Suppose there are two friends, you and another best friend of you, and a car is moving in this road, and you and your best friend standing in the opposite side of this road. Now, as you can see, the car is moving in this direction. Now, according to this person, the car is moving towards right, and according to this person, the car is moving towards left. So, if I ask you whose statement is correct, either this person or that person, the answer is both of them are correct. It's all about frame of reference. So, as you can see, anything we observe, this frame of reference is very important, because if we change our frame of reference, the entire value, the entire reading, entire observation can be different for different position. So let us try to define frame of reference. So what is the definition of frame of reference? A frame of reference or a reference frame consists of an abstract coordinate system and a set of physical reference points that uniquely fixed locates and orient the coordinate system and send standardized measurement within that frame. Now what is the meaning of this? See, this is a standardized system that we always take x, y and z coordinates. Now if we need to measure something, we first locate that in a specific position, and that is very unique. Why it is unique? Because its location and orientation is unique. We cannot rotate the axis, we cannot change the position of this O point, so that is why it is uniquely fixed. And if we need to measure anything, we need to measure it with respect to this point. So that is the concept of frame of reference. So I hope this is clear. Now let me discuss about type of reference frame. Now there are basically two types. One is inertial frame of reference, another one is non-inertial frame of reference. In inertial frame of reference, Newton's first law of motion is applicable. But in case of non-inertial frame of reference, Newton's first law of motion is not applicable. Why? Because in case of inertial frame of reference, the frame of reference itself is not moving with any acceleration. So in this case, the inertial frame of reference, the acceleration of this frame of reference equal to 0. But in case of non-inertial frame of reference, the acceleration of this frame of reference is not equal to 0. Let me give you a small example. Suppose this is a lift and the lift is going in the downward direction, as you can see over here. So the lift is moving in the downward direction. So if you have ever get into a lift or elevator, what is your feelings when it is going down? What is your observation? Your observation is a weightlessness. We feel that our weight has become less for few seconds or few moments. The question, why these kind of things happen, why this kind of observation happen? The answer is, as the lift is a non-inertial frame of reference, that is why we feel this weightlessness for a few moments. So this is the concept of non-inertial frame of reference. But in our topic, in our discussion, we are not going to interact with this non-inertial frame of reference first. Whatever with the frame of reference we are learning in this chapter, in this discussion, will be an inertial frame of reference. That means we can apply Newton's first law of motion. So is it clear? Now let me take you to another very much interesting point, that is point mass. But before we discuss about point mass, let me ask you a simple question: what is point? Don't you think it's really pointless to define a point? Why? Because according to the definition of a point shouldn't have any length, breadth or height. So if a point do not have anything of that, then if I ask you what is the volume of a point, volume equal to 0. And if it's true, then what should be the density? Density equal to mass by volume. So that should be infinite. So can a point actually exist? To understand this, we need to get the concept of reference frame, and from where we are going to observe that things. So suppose this is your reference frame. Okay, so this is your point O, and you are going to observe something which is placed over here. Okay, now the distance between this point and this object, so this O and this object, suppose the object is P, if the distance is R, so according to the concept of point mass, if the dimension of this point, now suppose the dimension of this point is D, so if this R is very much greater than this D, then only I can define that it's a point mass, otherwise I cannot tell it. Now let me give you an example. This is our earth and our earth is revolving around the sun. Now in this entire phenomena, don't you think whenever we try to understand these things, we always considered our earth to be a point mass? The answer should be yes. Why? Because we take this earth to be like this, and earth is moving in a circular path. So it doesn't matter how much what is the dimension of our earth, but we always take our earth to be a point mass. Who gave us this right? The right we got that the distance from sun to earth is way larger than the dimension of earth. So this is the distance from sun to earth. The distance from sun to earth is very, very, very large than the dimension or the diameter of earth. So that is the reason we can consider that earth to be a point mass. Now let me ask you few questions. Suppose in which of the following examples of the motion can be considered to be a approximately point object. Number 1, a railway carriage moving without jerk between two stations. So this is a railway carriage and it is moving without jerk. That means it is not stopping between two stations. It's just moving and moving on a railway track. Can we consider this to be a point mass? The answer is yes. Why? Because if we try to understand the dimension of the railway track and the dimension of the train, yes, a train is way larger, isn't it, compared to bus or car, whatever it is. But if you try to understand what is the length of the railway track, it is way larger than the length of the train itself. So that is why we can consider this train is moving with a point mass. Next, a monkey sitting on the top of a man cycling smoothly on a circular track. Okay, so a man is sitting on the top, a monkey is sitting on the top of a man and the man is cycling smoothly. So can it be example of a point mass? Yes, because as I said, the man is cycling smoothly on a track. So here the entire cycle, the person itself and the monkey, entire system we will consider to be a point mass, as the entire thing is moving on a circular path. Let us discuss the third example, a spinning cricket ball that turns smoothly on hitting the ground. Can we consider to be a point mass? Here comes the interesting question. The answer is no. The answer is no. Why? If this answer is yes, then for a small ball, why the answer is no? We can consider a train to be a point mass. We can consider a monkey, a cycle, the person to be a point mass. But for a small cricket ball, we cannot consider the motion to be a point mass. What is the point behind that? The reason is here we are taking the spinning motion. So as long as the spinning motion is concerned. For a point, is there any dimension, that means length, breadth or anything else? No. So how a point can be a spinning motion? Isn't that true? So a point cannot have a spinning motion. So if a spinning cricket ball it is mentioned over there, I cannot consider the motion of the cricket ball to be a point mass. So I hope this is clear that when and where we will apply the concept of a point mass. Now let me take you to another point, the concept of rest and the concept of motion. So what is the concept of rest? When a body is not changing its position with respect to its surroundings, the body is said to be at rest, and when the position of the object is continuously changing with respect to its surroundings, then it is said to be in motion. Now, do you know this rest and motion, everything is a relative terms? Now, why? I am sitting over there. Am I in rest or am I in motion? Let me ask this question to myself. The answer is either rest or motion. I cannot answer a single way, because suppose this is our earth. Don't you think our earth itself is moving around the sun? Every planet over there is moving. Even our sun is also moving. So nothing in this universe is at rest. If everything is in motion, then how I can understand the concept of rest? The concept of rest you can understand by the concept of choosing proper reference frame. It's always depend upon the type of reference frame I am referring. Now with respect to earth, I am not moving because I am sitting at a proper position and recording my video. So that is why I am at rest with respect to earth. So if earth is considered to be my reference frame, then I am at rest. So this is the concept that rest and motion are always relative terms. Now let me discuss type of motion. Generally, when the type of motion is concerned, we can classify the motion in broadly three different ways. There can be other type of motions also, but we can classify them in broadly three different ways. Number one is rectilinear motion, and then circular motion, and then oscillatory motion. So if a car is moving in a straight road, it's a rectilinear motion. If there is a merry-go-round, and then it will be an example of circular motion. And suppose it's a pendulum, the pendulum is moving, it's a concept of oscillatory motion. So these are the broad classification of different type of motion. But if we need to classify motion in order to coordinate system, I will have three different type of motion. Number one is one-dimensional motion, number two is two-dimensional motion, and number three is three-dimensional motion. Now let me give you example. Suppose there is a particle which is moving in one dimension only. Suppose a car moving in a straight road. That is a good example of one-dimensional motion. Now what could be the example of two-dimensional motion? Suppose a player moving around the ground on the cricket field, that could be example of two-dimensional motion. And for the three-dimensional motion, what is the example? For three-dimensional motion, a butterfly moving around everywhere. So that could be example of three-dimensional motion. In this chapter, we are focusing on this one-dimensional motion. This is our topic of discussion. So you see, from the beginning, I have mentioned motion in a straight line. That means motion in a one dimension. So that was the introduction of this chapter. Now let me take you to questionnaire. Let me read the first question. Which of the following statement is true for a car moving on the road? Question number 1. With respect to the frame of reference attached to the ground of the car is at rest. So that means this is the car. This car is moving Now the question is whether the car is at rest with respect to the reference frame attached to the ground. The answer is obviously no. Why? Because as I said, the car is moving. The car is moving. That means it is moving on the ground. So with respect to the ground, how could this car be at rest? So the answer is no. This statement is not correct. Now let me take you to second statement. With respect to the reference frame attached to the person sitting inside the car is at rest. Now suppose there is another person, suppose this person sitting over there. With respect to this person, whether the car is at rest or not, what is your answer? Obviously the car is at rest. Why? Because if the car is not at rest, then how could the person can sit inside the car? So there is no relative motion between the car and the person sitting inside the car. So with respect to the person who is sitting inside the car is at rest. So obviously option 2 is correct. Now let me quickly read the option 3 also. With respect to the frame of reference attached to the person outside the car is at rest. Here also this is the person who is outside the car. So whether this is correct or not, the answer is no. The car is not at rest with respect to the person who is standing just outside that car, because the person is standing on the ground. So the ground is at rest with respect to the person. So how can this car could be at rest with respect to this person? So I hope everybody of you will accept that the option number 3 is also not correct. Now next question here. From the given example, find out the motion in 1 dimension, 3 dimension or 2 dimension. So first question, first option, a kite flying in the sky. Whether it is a 1 dimensional motion, 2 dimensional motion or 3 dimensional motion, anything moving in the sky, that means in space, so it have a volume. So which option is correct? Obviously it is moving in 3 dimensional. So the answer is, here the answer will be 3 dimensional motion. Now next one, a cricket ball hit by a player. Now here also if you see, if there is a player, the player is hitting this cricket ball, then it will be a 2-dimensional motion. Why? Because suppose this is a cricket ball, okay, suppose this is a cricket ball, this is a cricket ball, it is coming towards the player. Now he hit the cricket ball and the cricket ball is recoiled and moving in another direction. So don't you think it's a entire phenomena is happening in 2 dimension only? The ball is coming, the player hit the ball and the ball is moving in another direction. So the entire thing is happening in 2-dimensional plane only. That is why it will be a example of 2-dimensional motion. So let me write over here, it is 2-dimensional motion. Okay. Now next example, moon revolving around earth. So here you see, this is our earth and this is moon. Now if moon is revolving around earth, it is kind of elliptical path, you know. So if it is elliptical path, then obviously this elliptical path will be a 2-dimensional motion, because ellipse itself a 2-dimensional figure. So obviously the answer will be, here the answer will be two dimensional motion. Okay, now next example, move a motion of a stone in a circular path. So suppose you have taken a stone and a thread and you are trying to rotate it in this way. So this kind of motion will be a two-dimensional motion, one-dimensional motion, or three-dimensional motion. Obviously the answer will be two-dimensional motion. Why? Because it is a circular path and circle itself a two-dimensional figure. So your answer will be two-dimensional motion. Two-dimensional motion. So I hope you have loved this questionnaire and the discussion session. Now in this total discussion, what are the things we have learned? Let me quickly recapitulate. We have understood what is the frame of reference and why do we need frame of reference. Next, what is the concept of point mass, and an object can, when an object can be considered to be a point mass. So these are the very small, very little but interesting thing we have learned. We have also learned the concept of rest and motion and why they are relative terms, why there is no absolute rest or absolute motion. And we have also discussed the type of motion. So after that we are to learn about displacement, distance, and lots of interesting thing about this chapter. So I hope you have understood everything, but still now if you feel that if you have any doubts regarding this chapter, please let me inform and feel free to ask me that if you have doubt. So thanks a lot, thank you for watching. I hope you have understood everything. So keep watching these videos. Bye bye.